All right, guys, we're going to continue our lecture on Chapter 3. Let's go take a look. All right, so if we inspect the truth tables for the and or operators, if you pretend that true means 1 and false means 0, you'll see something interesting. 1 times 1 is equal to 1. Excuse me, I stated that incorrectly. I should have just typed it up rather than depend on this. Looking at the bottom of this, you could consider and to be the same thing as logical multiplication and or to be the same thing as logical addition. Now, why do you say that? Okay, now if we treat zeros and falses as the same, 0 times, let's do the and first. 0 times 0 is 0, right? 0 times 1 is 0. Yep. 1 times 0 is 0. Yep. The only case where you get a true up here is 1 times 1 or 1 and 1. So and equivalent to multiplication, logical multiplication, Boolean multiplication. Now how about addition? 0 plus 0 is 0. 0 plus 1, 1. 1 plus 0 is 1. And 1 plus 1 is, well, you'd think 2, but this is a math language in which you only have 2 possible values, right? 0 and non-zero. So 1 plus 1 equals 1. So you know your order of operations, how multiplication has higher priority than addition. Well, operator precedence also means that and has higher precedence than or. So, and not has a higher precedence than them all. All right, so let's see if we can prove some of that. I don't know about just typing what we've got here, but let's go into idle. Yeah, I guess we could type what they had, right? A is equal to true, B is equal to false, right? And if you do A or B, that's addition, right? And so a true plus a false is going to be a true. One or the other has to be true for that to result in true. How about A and B? Well, that's multiplication. True times false, 1 times 0, that's going to be false. Both of them have to be true for the result to be true. Now, what if you have more than just A or B? What if we have several categories going on, right? So I'm going to make this say T1 is equal to true, T2 is equal to true, F1 is equal to false, F2 is equal to false. And the reason I did that is just so that it's easy to remember. If it starts with a T, it's true, and if it starts with an F, it's false. Okay, so if we have this expression, A and B or C, what happens first? Well, wait, not A. We're not using A anymore. Well, I guess we could, but right? T1 and T2 or F1, right? So how does this get parsed? The and happens first because it's akin to logical multiplication. Multiplication happens before addition. So it's going to check T1 and T2. And T1 is true and T2 is true. So definitely that's going to be false. Now, why did I say that? They're both true, so that result's going to be true. And then once this is calculated, then the or is going to be calculated. And is either side of the or true? Yeah, because that one results in true, and even though this one's false, the answer's got to be true, right? Okay. How about if we had F1 or T1 and F2? Again, what happens first? The multiplication happens first, right? So T1 and F2, that's a true and a false. That's like 1 times 0. That answer is going to be 0. That's a false. And then false or false, definitely going to be false. And then you can throw a not in there if you want. F1 or not T1 and F2. That's still false because not T1, not has a highest precedence of all, so it flipped that true to being a false immediately. And false, of course, is going to be a false. And then false ORed with another false is still going to be false, right? So if you did not F1 or T1 and F2, this is going to flip F1 to being a true, right? Because it was false. And so no matter what happens over here, once you have a true on this side, true or whatever, the result's going to be true. All right, let's keep going. So we have our math operators. I thought we'd already seen this chart. We have our comparison operators. Exponentiation, star, star. Arithmetic negation, that just makes a number minus sign, right? Like -1 means take a 1 and turn it into a minus. Multiplication, division, and remainder. And then addition and subtraction. So this is an order of precedence chart, looks like. Doesn't specifically call it out as such, but we're seeing that, you know, exponents happen before multiplication and division, which happen before addition and subtraction. And then you have your comparisons, right? It's saying that they all have a equal level. And then below comparisons, you have not, and, or. And then lastly, the lowest one is just the equal sign. Why is that? So that you could do something like A is equal to F1 or T1, right? This is going to be the very last thing that's done. Absolutely everything has to be done before then, right? And so let's see if we can figure out a little bit more. I'm going to make up something stupid. 3 times 4 is less than 5. 4 plus 1 or 3 is greater than 2 times 2, right? Okay, so how do we evolve that? Resolve that. And by the way, if I had this expression in a program, I would use parentheses to make absolutely clear what order things were going on. The computer already knows what order things are going on, but it's real helpful for me to specify what order things happen in so that I make sure I understand the logic. But let's look. What's the highest precedence out of all of this? Star, star, well, we don't have any. Multiplication, let's go look. So we have a multiplication here and we have a multiplication here. So 3 times 4 is going to become 12, and that's going to be 4, right? So is 12 less than 4? Well, and then the additions happen, right? So we've done the multiplication, then we do the additions. So is 12 less than 5? No, that's false. Was 3 greater than 2 times 2? No, that's also false. Why did we do all that before we did the OR? Because all of the multiplications and divisions and the comparisons get done before the nots and the ands and the ORs. So we had to do all the math, and then we could do the OR. And the result, since this part was false and this part was false, is going to be that A is equal to false. So if we just print A out, definitely false. All right, so if I had been ready to write that, I would have done something like this. Probably, just to clear it up, right? And these are probably going to be variables or, you know, function calls or something, anything, anyways, rather than just 3 times 4. But anyways, you get the idea. There's nothing wrong with using parentheses to clarify the order, even if it's not going to change the order. It's helpful to do that to make sure that the computer is going to do exactly what you think it's going to do. Why not specify it? And yeah, if you know the rules perfectly, then you can write it in such a way that you're sure it's going to work, even if you leave out the parentheses. But then when you allow somebody else to edit your code later and they don't know the rules of precedence like you do, they make a change to it, they break the code. Still false. All right, so short circuit evaluation. If you have something like this, I should be typing this into a real program file, right? Rather than just if sick is true and tired is true. And then you're going to have this expression. If you are sick or tired, print stay home, right? Or means if one side or the other is true, right? So you don't have to be both sick and tired to stay home. Either one's good enough. With that in mind, if we're sick, do we even need to check that, right? If we're allowed to stay home whether we're sick or tired, checking the first one is enough if it is true, right? What if it was a lot more trouble to determine if you were sick than if you were tired, right? You can just determine if you're tired by how you feel, right? To find out if you're sick, though, you have to, use a thermometer and wait 2 minutes in order to get the results. This check is faster if we do it in this order, right? The other order would have required us to check to see if we were sick first. And if we were sick, then we could stay home. But if we were not sick, we would have to check the second condition, right? So this is the more expensive check time-wise, meaning that we would want to write it like this, right? We want to check the least expensive first, because if that one's true, we don't even have to bother determining that we're sick before we decide to stay home. So, if this takes 2 minutes to check and this takes 1 second, then we could be done possibly with this check in 1 second. Now, that's one way to think about it. The other way to think about it is to check the one that is true most often. Because if we're tired 99% of the time, but we're sick only 1% of the time, then we should check to see if we're tired first, right? Because we don't want to be checking something that's false 99% of the time, which would require us to do both evaluations. And when I say require us to do both evaluations, the computer is going to do both evaluations. All right, so you just need to keep that in mind. Using OR, if the first operand, the thing before the OR, if the first clause is true, the check for the second clause is skipped. That's called short-circuiting. Short-circuiting isn't bad. It sounds bad, right? Captain, the engines have short-circuited. No, it's not bad. It's a good thing, generally, right? Speeds up the evaluation. So rules of thumb. When using OR, put the expression that is most likely to be true first, so that only one of them has to be done a majority of the time, right? If we're tired 50% of the time, but we're sick only 1% of the time, we'd rather check to see if we were tired first. Because otherwise, 99% of the time, we're going to find out that we're not sick, and we're going to have to do the second check regardless. Whether otherwise, whereas 50% of the time we could rule out entirely based on the first check, because if tired was true, we don't have to do the second check. All right. Now, Python is not that fast of a language. where the millisecond required to check the second expression is going to make or break your program. But you're learning skills that are not just applicable to Python, right? You may wind up writing programs in a very fast language like C, C++, something like that. And in which case these guidelines are very important. All righty. So that's short circuiting of the OR. How about and? I have money, right? And I am hungry, right? So if I'm hungry and I have money, print, go out to eat. We don't do much of that anymore, right? In the age of COVID. So here we go. We can't go out to eat if we don't have money. We're not likely to go out to eat if we're not hungry, right? Kind of pointless. I guess if we're hungry and we don't have money, we could borrow money from a friend, but you know, we're not going to depend on them for this particular logic. If this is false, we don't even have to check this, right? Because both of these have to be true for us to go out and eat. So since both of these have to be true, if I'm not hungry, I don't even need to check my wallet for money, right? So that's also short circuiting. Using and if the first clause is false, the check for the second clause is skipped. So the rule of thumb is reversed. You want to put the condition that is least likely to be true first, because if this is false, then this check is skipped and the computer can save some time by not having to perform the second check. So when using, so rule of thumb, when using and, put the expression most likely to be false first, just to encourage short circuiting, to enable it to happen more often. One important thing to note about that is that you're probably not going to write code that does this. But if you had some code that called a function that returned a true or false, and you had another function call there, then you would need to know that this function would not be called if A was false. And that's probably fine. But if somehow, some way, you wrote code that depended upon both of these being called, if you made the assumption that both of these were called, if your code was written in such a way that it would fail if both of these were not called, one after the other, then sticking them in an OR like that would be a bad idea. If that was the case, what you would want to do is gather the evidence first and then present it for the court, right? R1 is equal to A, right? R2 is equal to B. And then you could say if R1 or R2, right? You do the checks, both of them get loaded, both of them get accessed as was required in your code, which is not good programming, right? We're kind of doing a workaround against what was probably a bad design decision. But just keep that in mind. If you are making function calls inside your OR statements and your if or, yeah, mixed in with ands and ors, it might be a good idea to go ahead and get the results first, storing the results of those trues and falses in variables, and then writing that down. Excuse me, and then checking it in an if statement afterwards. So if your if statement requires function calls, to run, then you might store the results of the function calls in Boolean variables beforehand. Now, these are bad names, right? You might want to do something like if file open and if file written, right? And then we could check and we could write something like if file is open and file is written, right? Like that. I can't come up with a good way of, a really good example of that, because I would really try not to write something that would do that. But it's perfectly valid to store the result of an operation in a flag and then check it like that, rather than put the expression, the function there. I mean, you could do that with anything, right? You could say, you know, if the temperature is 50 to 40 degrees, and then you could say cold or ice is equal to temp less than 32, right? Because that's the freezing point. And then you could say if ice, do something, print burr, right? Like that. You could store the result of an expression there rather than put if temp is less than 32. That's called setting a flag. Ice is our flag that's going to dictate how the if statement runs. So tips, make sure that all possible branches and or alternatives in a selection statement are exercised. This is testing. When you're testing, you got to make sure that you test all the conditions that are true and all the conditions that are false. So after testing all of the actions, examine all the conditions. Test the conditions that contain compound Boolean expressions using data that produces all possible combinations of values of the operands. All right, now there's a quiz question that's very misleading. You're going to see this all possible combinations, and you're going to want to answer the quiz question one way. I'm going to just flat out give you the answer to the quiz. It'll say, how should you do testing? And the answer is with a reasonable set of data. Another option is run once. No, that doesn't test your program. And run with all possible combinations of data, which sounds great. Well, I'm going to run it with all possible combinations of data. All right, then, if it asks for a age, are you going to enter 2 trillion different numbers to test to make sure all 2 trillion numbers work? If it asks for a name, are you going to try every possible name in the universe? No, you're going to try with a reasonable set of data. That doesn't mean that you can skimp on it. You need to test it with data that will try out all of the if statements, right? So if I was going to test this program, I'd want to test it to make sure that I could get the burr message, or if there was an alternative that I could see the other one, right? So I at least want to check something that was both below 32 degrees and above 32 degrees. And I would need to decide what's supposed to happen at exactly 32, whether something is ice at 32 degrees or only below. That's called the edge case. And you want to test those too, right? You need to make that decision. And then you need to test for it as well in your logic. So please remember that in the quiz, how do you do your testing with a reasonable set of data, not all possible data. Okay, if you can test with all possible data and it's easy to do so, great, go ahead and do that. But normally the amount of data that you can try to test with is, nearly infinite. The while loop can be used to describe conditional iteration. Example, a program's input loop that accepts values until the user enters a Sentinel value that terminates the input. What does that mean? That's all fancy talk. That's like doing something like this. Enter test score or -1 to exit, right? This could be a loop. And then they type in 100. And then we could ask them again, enter test score. Why don't I just copy and paste, right? And so then they type in a 90. And then we run it again. Get rid of those little dots there. And we type in -1 because we are done entering test scores. and then we could print out two average over two tests, 95%, right? So we were able to stop at that point. This is called the Sentinel value. Or they just shorten it and call it Sentinel. Why don't we copy and paste all of this into our notes over here? I seem to have some more sick and tired. Don't know why. Looks like a duplicate of that one, so I'm going to delete it. All right. There we go. Let's make this a multi-line comment. No, that's not how you do multi-line comments in this language. There you go. So how would we code that? Well, we need a counter to keep track of the number of tests. And we need a counter to keep track of the test scores themselves. So I'm going to declare a variable called num tests and set it equal to 0. They haven't done very many tests yet. They haven't done any. Then we're going to set our total so far equal to 0. And then we're going to have a while loop. All right, I'm going to code this one way that I don't really like doing because I want to avoid using a break statement. So this is classical programming, but then the book shows a different way that I greatly prefer. So I'll show it to you in a minute. All right, so then we would ask them, enter the test score, print, enter test score, or -1 to exit. Right? Or why don't we just make this a normal input statement, right? Score equals double parentheses, quote, enter test score or -1 to exit, right? Like that. But I forgot to put the word input in here. There we go, right? And then we check, did they type in a -1? If score equals -1, no. As long as the score is not equal to -1, then we want to add it, right? Total plus equals score, and we want to add 1 to the number of tests. Number of tests plus equals 1, right? And then we have to ask again, right? Because this is asked before we get into the loop. And this is now being asked once we have added that stuff to the score. So this is how to do a Sentinel value test using what's known as a priming read. The priming read is like priming the pump. You got to pump a little bit before the water starts coming. And then once the water comes, you can fill the bucket and decide when to stop. So we have to decide our initial piece of data outside the loop if we do it without a break statement. I would rather do it an alternate way using a break statement. And that's using something called a while true loop, which is it sets it up to be an infinite loop, except we're going to have a break statement in that it stops it from being an infinite loop. So I'm going to reset our values, right? And then I'm going to have while true, right? And then we're just going to ask them, oh, score equals double input, right? And then we're going to check. If the score equals -1, then break. Otherwise, we can go ahead and add it, right? Total plus equals score, and then num underscore tests plus equals 1, right? Hope that makes sense. And then calculating the average is as easy as dividing the total by the number of tests. But there's a twist, which is what if they did not enter any data? If they typed in -1 right from the get-go, then we would not have any tests. And when we tried to divide, we'd be dividing by 0 and we would produce an error, probably crash the program. So we'd probably want to do something like this. If num tests greater than 0, then we could calculate the average, right? The average is equal to the total divided by the num tests. And then else we could just say that the average was 0, right? Because they had not taken any tests. I don't know if that's an average, if that's a mathematically correct thing to say, but I think it would make sense. And in print, the average over, let's do one of our usual things where we use an F here. How did I phrase it up here in my comments? The average over 2 tests, 95%, right? So average over num underscore tests is average, right? Let's see if that works. I think I'll comment this out so that I don't have to see both of them run, right? Because otherwise I'm going to have to type in even more data to get it to work. So I've commented out that example, the priming read example. Example of Sentinel test while loop using a priming read. And then this is, why don't I put my L there, make myself look smart. Here we're going to put in, this is an example of a while true break loop for Sentinel value while loop. Right? Like that. And I'm proud of this book for showing the ability to use a break statement to do that kind of thing, because most books want to remain proper computer science and they seem to avoid using break statements in the middle of the loop. Well, what does a break do? It just causes it to exit the loop. So as soon as it hits the word break, because we typed in a -1, it jumps down here. All right, let's try it out, make sure it works. Oh, why did I put double there? I'm supposed to put the word float. I'm sorry, guys. I just got done teaching about 12 hours of C#, a language that uses the word double rather than the word float. Got to fix that in both places. All right, let's let it go. Run it again. Here we go. Test score. I made 100. I made a 90. I'm tired of entering data. The average over 2 tests is 95. I think I'm going to put the word test in there, right? So the average over that many tests, parentheses S, in case we only enter 1, right? Let's see how that looks now. Enter test score 100, -1, we only did 1 test. The average over 1 test, you know what, I'd almost like to use an if statement so that we only print out the singular there. Otherwise, we print out the plural. So if test underscore num equals 1, then our word is just test, right? Else the word is tests. And then we could put that here, right? Using our placeholder. like that. And that way, if we've only got one test, it's not going to add an extra S. That's just being picky, but it makes the output look nicer. You know, so that we don't refer to one tests. Here we go. We're going to type in 100 and we're going to quit. Oh, look at that. It wasn't test num, it was num tests. I got a syntax error by not remembering my variable name. It was num tests. All right, 100, -1 to quit. The average over one test was 100. Excellent. Now let's try multiple scores. Always check all possible paths through the program. If we just type in -1 right away, we don't take any tests. The average over 0 tests is 0. Good enough. And lastly, let's try 3 or more tests, right? There we go. The average over 5 tests is 92. All right. So that's a while loop. A while loop just keeps looping until a condition becomes false. Something like this is known as an indefinite loop. It's an indefinite loop because the program doesn't know in advance how many times it's going to repeat. The computer has no way of predicting how many test scores I want to enter. It's indefinite, right? So while loops are used for indefinite loops. Then there are times when the computer kind of does know in advance how many times it's going to work. And those can also be done with while loops, but there's a better kind of loop that's better set up for those. And those are counting loops, right? If we want to set up something that counts from 1 to 10, we can do that, right? Counter equals 1, while counter is less than or equal to 10, or we could just make it less than 11, right? Print the counter. That's going to make it count from 1 to 10. No, it's not. That's going to be an infinite loop. Why? Because I never change counter, so counter is always going to remain 1. And there it goes. So, got to increase the counter. Counter plus equals 1. That is an example of a definite loop rather than an indefinite loop, but it would be better expressed like this. For counter in range 1, 11, starting at 1 and stopping before you hit 11. So that would go from 1 to 10. And then print the counter. -1 to get out of that, and then it prints 1 to 10, and then it prints 1 to 10, right? So this is a definite loop. The computer absolutely knows that it's going to be counting from 1 to 10 because of that. So this is a definite loop. While loops are generally considered indefinite loops, although sometimes they are behaving in a predictable fashion, right? So even though these functionalities are the same, we've implemented them differently. This way requires fewer statements to do. In general, if you're going to have a counter loop, it's a better idea to use a for range. So that's a for range loop, but there's another kind of loop as well, a for value loop, which can count through a list or something like that. I'm going to make a list of numbers. It's going to be 100, 200, 300, like that. And then I'm going to count through those, right? So for value in list, print that value, right? It's another definite loop. It knows in advance what data it's going to be stepping through. So this is another definite loop, but it's a for value. These terms are terms that the book does not quite use. They don't call it a for value versus a for range. It's more computer sciencey or whatever, but you can get it, right? This is counting through a list or other collection of data, and this is a counter-based loop, so it's going through a range. You may wish that you could do it like you have done in other languages. If you're a C, C++, Java programmer, you've written loops like this where you create a variable and then you say keep going while I is less than 10, and then you say I plus plus. Python doesn't do anything like that, so just kind of jettison that idea. These are the two kinds of for loops that you have in this language. So in this kind of loop that we run until the user types in a value, the -1 is a Sentinel value. So a while loop is a conditional iteration. The condition keeps being tested to determine if it will continue. That's called the continuation condition. While condition, do a block of code, a sequence of statements. If you write it incorrectly, you can get an infinite loop. You saw me with an infinite loop when I forgot to add 1 to the counter. Something to note about the while loop is it's called an entry control loop because the test condition is tested at the top of the loop. Python does not have native support for what's known as a post-test loop. This is a pre-test loop because the test happens before the block of code. Some languages also have a post-test loop where it does a block of code and then does a test to determine if it should repeat it. And since the while loop is controlled up at the top, the statements might execute 0 times. Well, when would a while loop execute 0 times? Well, we've already got our example of that up here. When I typed in, enter test score or -1 to exit, if I typed in -1, that was supposed to be a while, not an if. I'm so sorry. If you've been wondering all this time, growing more and more angry that I was calling that a loop and it wasn't a loop, it's because I made the mistake. All right, so while the score is not equal to -1, well, if they typed in the -1 first thing, it's not going to even execute this code at all. So the minimum number of times that a while loop will iterate is 0 times. Now, your condition will probably be set up so that it'll run the block of code at least 1 time. That's normal. But it's possible if the continuation case is false right from the get-go, that it's not going to run this code at all. Let's copy that statement. Or maybe both of these and paste them into our notes. So while loops, here we go. Improper use can lead to infinite loop, which is just a loop that doesn't exit. It's also called an entry control loop. I don't care if you know that, but maybe it's up in a quiz. The condition is tested at the top of the loop, and statements within the loop can execute 0 or more times. Looks like I just accidentally deleted something. I don't know what I did there. All right, there we go. Now, in this language, if you wanted to do an exit control loop, where you wanted to break at the bottom of the loop rather than at the top of the loop, you could do that with a break statement. Some languages have this. Do some stuff, right? Print X while X is less than 10, right? So the test happens after the action. And this means that it's done a minimum of 1 time, right? Not 0 times, because it does this no matter what, and then it tests it. And it keeps going while that condition. Well, this language doesn't have that. If you wanted to do it, you'd use a while true loop. So X is equal to 1. While true, print X, right? And then you would do your check. You could update x, x plus equals 1, and if x is greater than 10, it's time to stop, break. That makes it a post-test loop or an exit-controlled loop, right? Because the check doesn't happen until the end. If you wanted to rewrite this so that it wasn't a while true loop, but the logic remained the same, you could do something like this. Keep going is equal to true. While keep going, how about we call that repeat, right? That's a shorter word. Keep repeating. While repeat, do this, but if x ever becomes greater than 10, in that case, repeat becomes false. Now, to me, a break statement is just a fine and dandy way of doing that. But if you wanted to avoid a break statement, you could do that instead, right? Where you could use a variable and you would not be putting while true there. And that might make you feel better about things. There's absolutely nothing wrong with doing while true. I believe we're going to see that in an upcoming slide. All right, so there's the while. And if the condition is true, it does the statement and then it does it again. Now, this arrow is pointing the wrong way. So this is a badly drawn slide. The arrow should go from the statement back to the question mark so it can be checked again. All righty, and here's an example of a slide where the indentation is totally messed up. There we go, right? And this is the exact kind of thing that I was doing where we were adding test scores. They're just adding numbers and printing the sum of them. We have a priming read up at the top. If the data is good, then we go ahead and do something, and then we do it again. Same kind of business. If you're going to calculate the sum of a range of numbers, you may as well use a definite loop. You may as well use a for range loop. Or you can do the same thing, of course, with a while loop. But I think the syntax is clear that way. I would strongly recommend it if you're just going through a series of numbers and you know the beginning and you know the end, you should use a for loop, a for range loop. So a while loop can be complicated to write correctly. It is possible to simplify its structure and improve its readability, not if you don't indent it correctly. There we go. And here's our example of a while with a break. And they say that it's simplified and improved readability. I'm so proud of them for saying that. I like that. I felt so alone for all these decades when I've preferred to use while true, break, and textbooks never validated that. So I feel so good about it. Within this body, the input datum is received, it is then tested, and the break statement causes an exit from the loop. Now, some people should argue that you shouldn't have break statements in a loop, or if you do, you should only have one. Or anyways, there's nothing wrong with doing it this way. It's a perfectly good way of doing it. You just want to try to make sure it's readable. All right, so apparently we're going to have the same example yet again. So what is this doing? This is an input validation loop. We don't want to allow them to enter a grade that's less than 0 or greater than 100. I guess we're ignoring that -1 thing where we were allowed to quit. This loop is not going to exit until they type in a number that is greater than or equal to 0 and less than or equal to 100. So that's an example of a data validation loop. Let's come up with another one. So while true, print enter test score or -1 to quit, right? But we're going to put that inside its own while true, which is going to look silly, but it's going to work. Let's set our total equal to 0. And then we're going to get our value, right? Score equals the float version of the input. Well, why don't I just take this, right? Why don't I just cut that and put this there like normal? And then we do our check, right? If the test score, if the score is greater than or equal to -1 and the score is less than or equal to 100, then we'll break because it's good data, right? Else we're going to print a message, right? Print score must be between 1 and 100, or 0 and 100. Must be between 0 and 100. All right, by the time we're done with that while loop, by the time it's broken out of that while loop, we have good data, so we can add it to our total. And we could have a variable called num tests again. It starts off as 0. And as soon as we get a valid piece of data, we add 1 to num tests, right? So this is the data validation loop. It makes sure that we get a good piece of data before we continue. Now we need to actually see if they typed in a -1, right? Because if they type in a -1, we're going to break the outer loop. We're done. And then we can calculate the average, right? Same business that we did up here. So I'm not going to repeat it. I hope that makes sense. This is what's known as a nested loop because we have a loop inside a loop. What we might have wanted to do is to stick this in its own function to make the code a little bit easier to read. And what would that look like? What I could do is I could cut that code and I could write a function called get_score. Define get_score, parentheses in, parentheses colon, and then just paste that code, right? But instead of breaking when we get a good score, we could return the score. Oh, this needs to be tabbed over properly, right? Because every time you have a colon, the next line has to be indented. Or we could return it down here, right? Either place is a good place to return it. We could return from the middle of the loop, or we could return after we've broken out of the loop. And then down here, we could call that, right? Score equals get score. I'd rather do it like that. And the reason why I'd rather do it like that is I may want to use this function somewhere else too, right? And so now the code is already written. I might want to genericize it a little bit so that it took a message, right? So I could put a parameter there and we could just print that out, right? Like that. And then when I ask for the score, that would be the message that I put in there. That way, if we were to ask for another value, we could. Now we could get all fancy and make it check for the upper limit and allow them to specify what the exit thing was going to be, or, you know, all that kind of stuff. But I think that that's good enough. I don't think that we need to belabor this. Let's add a doc string. Function that asks the user to enter a value. Value is checked to see if it is between -1 and 100. If it isn't, an error message is displayed and the loop repeats. Otherwise, the number entered is returned. All right, there's our docstring for that function. What is this an example of? This is an example of another test score data entry loop that uses our get score function for data validation. Alternative, using a Boolean variable to control the loop. Done is equal to false. While not done, get the numeric grade. If the number is greater than 0 and less than 100, then done is true. Else, print the grade must be between 100 and 0. And then at the end, we just print something to echo the valid input. I'm going to have to upload this fixed PowerPoints. So random numbers. Random numbers allow us to generate like die rolls, right? You're going to play Yahtzee, you wouldn't want to know the numbers in advance. So there's a random module that allows us to generate random numbers. Something like this, right? We're going to import random. And then we're going to get 3 random numbers. X is equal to random dot randint between 1 and 6, right? Y is equal to random dot randint between 1 and 6. And then Z is equal to random dot randint 1 and 6, right? And then we could print the total, right? X plus Y plus Z. Or we could have created the variable beforehand, right? Total equals X plus Y plus Z. And then replace that with the word total, right? Or we could use a formatted print where we put a $sign here and we use a placeholder with curly braces, but whatever. All right, I have a whole bunch of -1s to type to get out of these data entry loops, right? And then the total of the 3 random numbers is 12. Let's run it again. Make sure, I mean, we could have been printing these numbers too if we'd wanted to, right? Print, $, quote, placeholder X, placeholder Y, placeholder Z. And I've got a syntax error because you don't put a $sign there, you put an F there. All right, -1, -1, -1. Okay, so we got a 5, 5, and a 2, and the total was 12. It seems like that's the same we got last time. Let's run it one more time to make sure that we really are getting different random numbers. So we run it one more time. We enter our -1s. I need to go feed the cat. Here's a 1 and a 5 and a 2. And our total is 8. So here they're showing the same kind of thing, right? Except they're generating 10 numbers in a row by using a for statement. We can do that. Let's modify our code to generate these 3 random numbers. Well, how about just generating 10 more like they did, right? So for roll in range 10, we're going to generate 10 different rolls, right? X is equal to random.rand int. Let's generate a number between 1 and 20. We've decided that we're Dungeons and Dragon players and we want to use 20-sided dice. And then we can print the roll number. This is going to count from 0 up to 9. Maybe I'd rather count from 1 to 10, so I'm going to change that to 111. So we're going to print the roll, which is actually the roll number, not the roll itself, right? I don't really like that. I'm just going to call that N, right? And then I can say that this is the roll. And so I could say roll number, curly brace N, and curly brace equals curly brace roll, right? In curly brace, in quote, in parentheses. Here we go again with the negative ones. I think we're going to have to end the lecture soon just because I'm getting tired of typing negative ones. Yeah, I could comment them out, right? But we're also about at the end of the chapter. Okay, so here we go. And it did repeat from 1 to 10, doing that. And so here's a simple guessing game where we ask for the smaller number, we ask for the larger number, and then we pick a random number between those two values. And when I say we, the computer is. And then while true, we add 1 to the count, we ask for their guess. If the guess is too small, we display that. If the guess is too large, we display that. Otherwise, lastly, we print you got it. This seems to be off the edge of the slide. No. You got it in certain number of count tries. That's cool. I would copy and paste it, put it into our code, except I'm going to have to change the quotes. But at least it's indented. All right, let's fix the quotes. Can't use those matching quotes. Got to be just straight up and down quotes. Microsoft Office thinks it's so cool putting in those matching quotes, but I'm sure it doesn't work well with programming languages. Kind of too bad. All right, so here we go. Got most of them fixed. I'm going to change the way this prints. Nah, I'm going to leave it alone. I was thinking about adding the F here and then going ahead and putting the braces, but nah. All right. Let's run it, make sure it works, because I don't want to post code that doesn't. And it failed. Invalid character in identifier. This is a problem from copying and pasting the code. Oh, more of those quotes. Ooh, boy. If I could do search and replace on them all. I think I've got them all now. Rand int, there should not be a space between the two. if there was a space between the two in the, no, there wasn't. So I wonder why it added one. All right. Try once more. All right, so enter the smallest number that we want to guess, 10. The larger number is a 20. Enter your guess. Oh, how about 10? How about 15? Halfway between the two. No, that's too large. Oh, and it didn't repeat. Let's go see if we can figure out why. It was supposed to keep going, as long as the values weren't not correct. It even had a while loop. All right, this break needed to be tabbed over to match that one. Let's see if it's that way in the PowerPoint. Nope, that's wrong. I know it looks silly, but let's just accept that I need to do it that way. All right. And heck, if I'm going to do that, you know what? I'm just going to replace that with the working code from here. Now we have a lot of stuff to clean up here. Let me pause the recording. All righty, now the slide is correct. I changed this print to use that syntax. I think I'll do the same for our code. This stuff is indented a little bit too much in my opinion, so I'm going to see if I can decrease the indent by highlighting it all and choosing Format Dedent. Yeah, that's better. I'm going to just change this to congrats, so the sentence won't be as long, because when I paste it in the notes, it wraps around in the next line. All right, so errors to rule out while you're testing a while loops. The loop control variable might not have been initialized, right? I might be reusing a variable that I had earlier in the code, you know, while x is less than 10, and if I had forgotten to reset x to 1, then it won't work. Or failure to update the variable within the loop. Remember when I had a loop that was supposed to just repeat 10 times and it went infinitely before I got, because I forgot to add 1 to the counter? That's a problem. Or failure to write the test correctly. If your program is hung, you can type in, supposedly, Control-C to get it to stop. And we could add an infinite loop and see if that actually works. I'm going to go up to the very top of the program, add an infinite loop. While sick, print. I'm sick. Okay, that's stupid, right? But let's just let it go and see if that Control-C lets us out. What did I do wrong? Seems to be something here at the end of my break statement. Well, that's been the wrong place. All right, surely it'll work now. All right, can I type in Control-C to get it to stop? Yeah, what do you know? It says keyboard interrupt. I'm going to go and delete that. Don't need an infinite loop. So the summary. Control statements determine the order in which other statements are executed, right? And so what are our control statements? If, elif, else, right? All those dictate, you know, a decision has been made and we're going to execute one block of code or another or a third. Then while, because the code might be executed or it might not. And a for, the code will repeat a certain number of times. And a break, which causes it to exit a loop early or just exit the loop. The word early is, superfluous. But if it was in a for loop and it was supposed to count to 1 to 10 and then encountered a break, it would break right then and there. So that's what I meant by early. So a for loop consists of the header set and the set of the statements called the body. You use a range to go through a sequence of numbers. You can use a % sign when you're printing things out to control how many decimal places. That's kind of really old school, and I haven't been showing it too much. Maybe I showed it last lecture. I don't recall. An off by 1 error occurs when the loop does not perform an intended number of iterations. Right? If I did for x in range 10, and I really wanted it to go from 1 to 10, it would count from 0 to 9. That's not really an off by 1. It's off by 1 on both sides. But if I wanted to keep it a while loop going while x is less than 10, and I made it while x is less than or equal to 10, that would be off by 1, right? Boolean expressions go true to false using the logical operators and or not. Python uses short circuit evaluation for compound Boolean expressions when there's ands or ors in there. And we talked about if it's an and, it's short circuited if the first clause is false because it doesn't need to check the second one to rule it out. If it's or, it short circuits if the first one is true. The second clause is not checked if the first one is true because there's no reason to. Selection statements allow programs to make choices. I like the way this is kind of terse, like Tarzan said it. Selection statements enable program to make choices. Actually, if you've ever read the Tarzan books, he was, spoke like he was educated at Harvard and maybe even was or whatever. So making him talk primitive like that's silly. If else is a two-way selection statement, or you can do if else. A conditional iteration is a process of executing a set of statements while a condition is true. You can use a while loop. You can put a break in there to exit the loop. Any for loop can be converted to an equivalent while loop while the reverse is not true. An infinite loop is when the continuation condition never becomes false and there's no other exit, there's no break. And then random.randint returns a random number. All right, so just for funsies, homework's going to be pretty simple on this one because I kind of assigned a lot for the last time, I believe. So homework, write a program that asks how many dice to roll. Have your program loop using random numbers to generate that many numbers. Display the total. So an example of that, right? How many dice should we roll? And the user types in 10, right? And so we could say, roll 1, we got a 10. Nah, we got a 5. Roll 2, we got a 7. Roll 3, we got a 3. Roll 4, how did we get a 7? I guess we're using something more than a 6-sided die. Let's change it like that. Roll 5, and we got another 1. Roll 6, and so on. I'm going to stop talking. Alrighty. And the total of that is, now let's figure it out, right? That's 24. That's 30, and that's 33. Might be wrong, but I think it's right. All right. I think it's good enough. That ought to be pretty easy, but if it's not, if you get stuck on it, go ahead and text me and ask for help. All righty. So I will see y'all in the next lecture.